important topic in project management called as critical path analysis. So this is useful in many aspects, not only in software engineering but in many other fields. So it will be useful to plan and organize our tasks depending on various dependencies. So before starting the program, I will explain some of the important terminologies. So basically, for critical path analysis, we will construct a graph. So here we can see the requirement and development testing, those are connected through the edges, so we call it edges. And when we have a node which is the requirements or design, these are called as nodes. So node successive to a previous node, it is called as successor. So here design is a successor and requirement is called as a predecessor of the design node. So this is basically the terminology we need for the critical path analysis. So what is critical path is, so let's say we have a task called requirements and it takes 2 days, and we have a task called design which takes 3 days, and we have a task called development which takes 4 days. So critical path is the one where we should not have any delays. That means, let's say after completing the requirements, we have to immediately start on the development, then we call that is under a critical path. If we can delay 1 or 2 days, then it's not a critical path. So with that understanding, we will dive into the topics. So I will show the program. So here, as we know already, so we will use these 3 libraries. So basically we have used pandas, networks, and as already we are familiar with matplotlib, we are using matplotlib. Okay, so here there are 2 important concepts in critical path. So one is early times and one is late times. So what is early time? So early time means, as I explained, so once we have a graph which we have defined as a topological sorted graph, so if that graph contains a predecessor, so let's say you have a design, so design will require a requirements, so requirement will be the predecessor, so design will be the successor of requirement. So in this case we will consider, so requirements will not have any other predecessors. So if there is no predecessors, then we can immediately start it. So that is earliest start, ES. So ES we can set it as 0. And if there is a 2 days duration for the task, then we can finish it by that 2 days. So we are setting the duration to the nodes without any predecessors. So this is for the nodes without predecessors, which is requirements in our case. So else what we can do is, we can check the previous task, and whatever which takes maximum times will be used for our earliest start, because unless we finish the previous task, we can't start the current task. So earliest start will be the max early finish, and once we have the earliest start, then we can calculate the earliest finish by using the duration. So this will give the early time. So earliest start will be maximum of early finish for a node. So early finish is nothing but the maximum of the predecessor's earliest finishing times. So for first node, we will initialize it with the duration. For other nodes, it will be calculated recursively. Okay, so these earliest start and earliest finishing times we can retrieve from this above function, and similar way for late times we can calculate from the reverse order. So what we have to do is, first we will calculate the latest finishing time. Latest finishing time is nothing but the minimum of successes starting times. That means whenever there is a successor, successor is nothing but design or development, which will be the successors of requirement. So those minimum time required for them to start is the latest finish time we can have. So minimum of latest start is the latest finish time. By default we will have early finish times for the first node, and then once we calculate we can assign the latest starts of the successes to the latest finish times. Okay, and latest start will be given by latest finish minus the duration. That means from the final node we can calculate this. So final node will have the latest finish time, so that latest finish time minus the duration it takes for the task is the latest start time. So this is regarding early times and the late times. So that means earliest start, earliest finish, and latest start, latest finish. So with that understanding we will see what is the critical path. So critical path is nothing but the latest finish time and the earliest finish times will be same. That means latest finish time minus the earliest finish time should be 0. So that is the one we have defined at this step. So before that I will explain these steps. So here, as we all know, we have defined a critical path depending on the delta. Delta is nothing but the latest finish time minus earliest finish time. Okay, and for visualizing I am using networks, and as we already familiar, we are using the matplotlib. So for networks I am using the planar layout. You can use any other layouts which are supported in the networks. And here I am coloring the nodes by red if it's in the critical path node, and I am having this durations and the latest finish times of these particular edges. So here I am using the f-string method, so you can also use string concatenation or other forms to derive this, but it's very easy to use the f-strings. So with that understanding, this is useful for visualizing purposes. And here I am using basically a pandas data frame. So here we have used the pandas library. So pandas will work very well with the networks. So I am using the pandas data frame. Data frame is easier for doing the calculations and some data manipulations we can make with the data frame. And I am using the networks library, and I'm initializing a graph with the digraph. So these are initializations, and once we initialize, I am passing the data from the main method. So data will be of this format, basically a dictionary which contains the task duration and the dependencies associated. So here I pass the requirements, design, development, testing, and other tasks associated with the project and the respective durations, and the dependencies are mentioned below. So here we have certain tasks will have more than one dependency. So for that one, here we are handling first I am getting the particular node and check whether it's the instance of list, because sometimes it will have more than one dependency. So if it's more than one, then I am adding an edge for both dependencies. So whenever there is a dependency, we need to add an edge. So if it's a single one, we have to add only one edge, and if it's multiple one, we have to add more than one edges. So After that I will have a constructed graph, and using that I can calculate the early times and the late times. So here I calculate the early times and the late times using the previous functions we have created. So we have an idea on the early times and the late times, so we will use that in the execution. And for each nodes I am calculating the delta. So this is where the critical path concept will be used. So whenever there is a node with latest finish and the earliest finish on the same time, it will be delta will be 0. So when it's 0, then we will take that node in the critical path. So for all the nodes in the graph, we will have the delta values, and depending on the delta values we can filter out which is a critical path. So that's what we are doing. So for critical path I am calling the identify critical path on top of this graph, so that will return the nodes which are in the critical path. And once we get this critical path and the respective graphs, we can visualize it. So we will run this. So here you can see there are some nodes and their respective duration. So when you see this requirements, so requirements will be having two dependencies as we defined in our program. It will have two dependencies. Basically the requirements will not have any dependencies, but requirements will be used in many other places. So here we can use for development we need requirements, and for design we need requirements. So both will require this node. So that's why we have two edges, as it's dependent see for design and development. So similar way for other things, like for documentation we might need the design and the development, so those will be the dependencies. So similar way we have constructed the graph, and once you see this graph you can get an idea, like here we have put the latest finish time and the duration. So latest finish time will be the one used in our critical path and analysis. So latest finish and the earliest finish times should be equal. So here we have durations in our edges. So here latest finish time will be calculated by using this method. So latest finish times will be calculated by using this method, minimum of the successor node. So when we are traversing backwards, that is backtracking, we will get this latest finish times, and latest finish time is nothing but the minimum of the successor node. And for first node we will have the earliest finish times, that is earliest finish time will be first for first node it will be the duration. Okay, and once we construct this understanding, we can use it for different purposes. So let's say you want to create a dependency graph for your project, you can pass it in this dictionary as an array, and you can check which will be the most critical one. So for our project we have this understanding, like everything is under critical path. So when you see, you can just print and see whether you need everything. So for this one, if you rerun again, so you can see these are the nodes under the critical path. So everything will be required in our cases. Okay, so with that understanding, I think you can utilize this concept in various programming projects, and we will discuss some important topics in the upcoming series. Thank you.